Hi guys, welcome to inverse variation. We're going to see what methods can be used to write and solve equations using inverse variation. So what is inverse variation? Well, we're going to start out with knowing what some of the parts are. K is what we call the constant of variation. It's your unknown value, but he's also a constant, so he's going to say the same number throughout the problem. We have a formula, y equals k over x. And what this basically says is y, that's one variable, x is the other variable. As one of your variables gets larger or increases, the other one decreases. And that's what we mean by varies inversely. That means one variable goes up, one goes down at the same time. So an example of that, the length of time it takes water to boil, so the length of time it takes water to boil varies inversely as the temperature. So the length of time is equal to K over the temperature, T. So our variable M is going to be going down as T, our temperature is going to be going up. That's why one is on top of the fraction and one is on bottom of the fraction. That means the higher the temperature, the less time it takes to boil. So inverse variation, an interesting little concept. Let's practice some problems with it. Our first example, the length of my legs varies inversely as the steps I must take to cross the room. If it takes me 62 steps and my legs are 30 inches long, we're going to find the constant of variation. So let's put all that together. I know I'm going to have a couple of variables, and K is going to be on top. That was my formula. The first one says length of my legs varies inversely as the steps I must take to cross the room. So L, and that's a cursive L because my L's look like ones, equals K over S. That varies inversely. Now, we got some numbers given to us. So we're going to plug them in. So 62 steps. And my legs are 30 inches long. And now we're going to find actual K. We're going to solve for K. Well, you know how to do that. Cross multiply. So you've got K equals 30 times 62. You put him in the calculator and you get 1860. That's your constant of variation. Ta-da! You solved a problem. All right, let's try another one that's slightly different. Again, the length of my legs varies inversely as the steps that I take to cross the room. Again, I have 62 steps when my legs are 30 inches long. And the question now is, how many steps would it take if my legs were only 20 inches long? So I'm going to go back to the same thing we did before. Our legs vary inversely with our steps. And we plug in the first set of numbers, just like we did before. And we got 62 steps, went with 30 inches. And when we solved this, we got our constant to be 1860. Now that's only half the problem. The last part says, how many steps would it take if my legs were only 20 inches long? So I'm going to go back to my word problem, my formula. I want 20-inch long legs. I want to know how many steps, and I know K. So I changed it from 30 inches to 20 inches, so that means the steps are going to change. But we do know how to solve this. We can cross multiply. So I have 20 times S equals 1860. Divide by 20 on both sides to get S all by himself. And it's going to take me 93 steps. Look at that. We solved it. All right, let's try another one. The length of my legs varies inversely as the steps I must take to cross the room. It takes me 62 steps when my legs are 30 inches long. How long would a person's leg have to be if it was 60 steps they took? Okay, I'm going to do the same idea. My legs vary inversely with my steps. We plug in our stuff that we knew. We knew that our legs were 30. Our steps were 62. And when we solved that earlier, we got our constant to be 1860. And then we go to the other half of the problem. This part of the problem says, how long would a person's legs be if it took them 60 steps? So we have the length. We already know the 1860. And it's 60 steps. So our 1860 goes in there for the K. Our 60 goes in the bottom for the S for the steps. We're trying to find L. Well, we know how to solve that. You can just put that in the calculator, divide those two numbers. 1860 divided by 60 is 31 inches. All right, let's try another example. Wyatt, he can do a job in 4 hours. Michael, it takes him 6.5 hours to do the same job. Maybe it's painting a house or, fixing a car, whatever. Mowing grass. Which equation shows how long it will take the boys to complete the job if they work together? The idea is they work together. So how long does it take Wyatt? 4 hours. Remember, this is inverse. So 1 over 4. And how much does it take Michael? He's 1 over 6.5. And if they work together, it's 1 over x. That's our equation. Pretty nifty. You just take 1 over each of their pieces equals 1 over x. So Wyatt does it in 4. Michael does it in 6.5. How many together? The together would be the x when we have to solve those. We're not doing that today, but that's how you would get there. So our equation, 1/4 plus 1 over 6.5 equals 1 over x. Okay, let's try another one. A large cylindrical water tank has 2 connected pipes. The inlet pipe is used to put water in the tank. The outlet, so the inlet puts water in the tank. The outlet takes water from the tank. The inlet pipe can fill a tank in 10 hours. The outlet pipe can empty the tank in 15 hours. We're going to formulate an equation that can be solved to determine how long it will take to empty the tank if both of them are operating. So let's try that. So we have an inlet that's putting water in the tank. It's 10 hours. But we're taking water, emptying the tank at 15 hours. And we want it to be equal to both of them working. There's our equation. 1/10 minus 1/15 equals 1 over x. Kind of like the one with Wyatt and Michael on the last problem, working together. This one's working together, but one is filling and one is emptying. That's why there's a